Can I ask you two general questions about the test? Very general. One, will there be a discussion going over it in class afterwards? Will there be an answer to be given to explain?
No, if you're allowed to retake it.
When do we have? When do we ever get to know what we did? Like,
Because I'll grade it, right? So you'll know what you did wrong. And I leave
well,
comments.
I'll know I got something wrong, but I won't know how to do it.
I leave comments. And then you can come see me afterwards and we can discuss it.
And secondly, how much is the graph worth on the profit cost part? The graph part of it? Because I'm pretty much certain, I have no idea how to, but it has to be attached to the PDF somehow?
No, you can upload a screenshot of that separately.
But it has to be done then with the computer version calculator.
Or you can do it on right-click and take a
Okay,
picture of it with your phone.
but,
That's also fine.
okay.
I think that it's what, 3 parts?
Yeah,
Is the graph one whole part?
I don't know, I couldn't print out, you can't print out the test, I guess, can you? I couldn't figure out how.
I don't know if it allows you to do it or not. It should if you open it.
Technology once again.
Yeah, it is one whole part, so it'd be about a third of the points. Right, because you have to graph and then you have to use the graph to determine maximum profit. I can show you how to graph on a calculator after class.
That would be nice. I mean, I think checking my answers into the equation, I think I really feel confident I found the profit. I just can't figure out how to graph this stuff.
By the way, that one is the ass kicker.
Yeah,
That problem's the one that if you want to get an A, you have to know what you're doing. I always include one of them on there. What's today? Wednesday? Happy Wednesday. We're done with the introduction to functions, right? So we're going to start looking at different types of functions. For the most part, the first 2 meetings of this unit should be review. You should have covered this in an algebra course. Today, we start with the complex number system. Monday will then be quadratic functions. I go a little bit more in depth on quadratic functions than you do in a typical algebra course, but still quadratics, so it's still the same as algebra. All right. Just about everything we've been doing up until this point has been in the real number system. All right, you start arithmetic, you start with integers. And then you move up, and I think after integers, the next thing you study is fractions, which are rationals. Then you start to study the irrationals, which are the real numbers. So they're all real numbers. That is not the only number system, right? If we look at it. The simplest number system is what's known as the natural numbers. Depending on the reference that you look at, they're either the set of 0, 1, 2, 3, so on and so forth, or the set of 1, 2, 3, 4, so on and so forth. Some include 0 in the natural numbers, some don't. I'm in the don't camp. Another term for the natural numbers are the counting numbers, right? Which is why I do not include 0. If you're counting, you don't typically start with 0, right? You don't go, oh, your number's 0. That's kind of insulting, right? You start with 1. After the naturals come the integers. So these are all the naturals. They're negatives and 0. Well, every natural number is an integer, right? Is every integer a natural number? And so natural numbers are a subset of the integers. The integers contain the natural numbers. After the integers, you study the rationals. A rational number, by definition, is any number that can be written in the form of an integer over a non-zero integer. Is every number, or is every integer, a rational? Yes, right? You can write every integer as the integer over 1. So the integers are a subset of the rationals. Double check. Yeah. After the rationals is a number system that is commonly left out. Called the algebraic number system. Algebraic numbers are numbers that are roots of polynomials, which is convenient because that's what we're going to be studying right now. I should specify actually, that isn't really, that's like up here somewhere, because complex numbers can also be algebraic. Right? Algebraic numbers are just solutions of polynomials equal to 0. Then you have the real numbers. The real numbers are every rational number unioned with every irrational number, right? So an irrational number is a number that cannot be written in the form of an integer over an integer. Pi is an irrational number. Square root of 2 is an irrational number. Root 3 is irrational. In decimal form, irrational numbers are easy to tell. An irrational number does not have a repeating decimal, nor does the decimal terminate. Any number that has either a repeating decimal or a terminating decimal is rational. Right? So 1.2828282828 is rational. It repeats. As an interesting aside, 0.9 repeating is equal to 1. doesn't seem to make much sense. Well, clearly every rational number is real. After the reals, is the complex number system. Complex numbers can be written as A plus BI. A and B are real numbers, and I squared is defined to be -1. I is still called the imaginary number. It was kind of like, we're just going to define this so we can take the square root of negatives. We're just going to call it imaginary because you're not allowed to take a square root of a negative. And then, as it turns out, the vast majority of solutions out of quantum mechanics involve the number I. So it can't really be imaginary if it describes our universe. So now we call them complex numbers. There's also a class dedicated to the study of complex valued functions. So it's essentially calculus, but now on complex functions. You move on to the complex plane instead of the real plane. There are two ways to look at complex numbers, the algebraic way, A plus BI. There's also a graphical way. You set up an axis system like you would with the real plane. The horizontal axis is the real axis. The vertical is the imaginary axis. Right? So A is the real component of Z. B is the imaginary component. Well, then what you can do is just plot it on this coordinate system. As a vector. Real numbers, are they complex? Sure about that? Give me any real number.
Root 5. I mean, the zero is going to cancel that out anyway.
It doesn't matter. Zero is a real number, isn't it? So I wrote it in the form of A plus BI. All real numbers are complex. The imaginary component is what's attached to the I. Right, so in this case, you'd have real of root 5 is root 5. Imaginary of root 5 is 0. So the reals are a subset of the complex. It just would so happen that every single real number would just fall on the horizontal axis. This is where the fun gets. There are number systems beyond the complex numbers. What comes after the complex are called the quatrics. Right, those are numbers of the form a plus bi plus cj plus dk. And then there are conditions on the j and k. If you're familiar with vectors, so if you have to take physics and you start to look at cross products, that ijk behaved just like I hat, j hat, k hat in vector analysis. I cross I is 0. So if you multiply I with I, you get 0. I times j would give you k. J times k gives you I, and k times I gives you j. It follows a right-hand rule. Right, so those are the conditions in ijk. Then you have the octonions after that. Right, then it's the secternions. So on and so forth. In fact, 2 to the n, there's always a number system with that number of digits. Right, so the reals would be 2 to the 0, complex 2 to the first, the quaternions are 2 to the second, the octonions 2 to the third, secternions 2 to the fourth, so on and so forth. By the time you hit the octonions, you've lost every property of arithmetic that you have. Quaternions lost, if I'm remembering correctly, it's been a decade. The quaternions lose commutativity in terms of multiplication. Yes, it does, right? Because I times j is not j times I. They're actually negatives of each other. By the octonions, you've also now lost associativity, which means grouping now matters. Lucky for you, unless you're a math major, you don't have to worry about those number systems. I lied. You may have to, depending on your major. The octonions are particularly useful for rotating space. So that's used in physics. I don't know what the secternions are used for. Some kind of advanced stuff, probably. Right. That's what we're going to be focusing on today, just the complex numbers. All right, so we're going to be dealing with arithmetic of complex numbers. We are just dealing with the algebraic arithmetic. I am not touching geometric arithmetic, right? Because you can geometrically add complex numbers. You can geometrically multiply complex numbers. But I'm not dealing with that. There's one more term you need with complex numbers, and that's the complex conjugate. Right, so we represent the conjugate of a complex number with a bar over it. All right, so that'd be read z bar, and all it does is it switches the sign of the imaginary component. Just switches the sign of the imaginary component, right? So instead of a plus bi, it's a minus bi. There's also magnitudes of complex numbers, which we're not going to deal with. That is something you would study in a complex analysis course, which is senior level. So it's going to be dealing with arithmetic. Square root of negative 2 times square root of negative 32. Right? These are obviously complex numbers. Split it up. So 32 is 2 times 16, right? So I can actually rewrite that as 4/2. Yes, you look confused.
Isn't root 2 times root 32 root 64? Which is 8.
Right?
Oh, you haven't done the root.
Yeah, I haven't
Oh,
done the multiplication
okay,
yet.
I'm sorry.
I'm just rewriting these as complex numbers. Which, keep in mind, you're going to have to do first, right? You can't multiply this out and get, oh, look, negative 2 times negative 32 is 64. Therefore, the answer is 8 because it's
No, yeah, it's true. I wouldn't
Right.
do that.
This now works just like if I was X, right? So think of I as a variable. It'd be root 2 times 4 root 2. Root 2 times root 2 is 2. 4 times 2 is 8. Then it'd be I times I, which is I squared. Yes, because I squared is minus 1. So we get negative 8.
When you multiply 2 times 2, it just stays 2.
It's not 2 times 2, it's root 2 times
Oh,
root 2,
yeah, root
which is 2. Right, because it would be root 4, which is 2.
Multiplied it with 4.
Yep.
4 times 2. And I squared equals negative I.
Negative 1.
Negative 1.
Yep. Right, that's the definition of I. I squared is minus 1.
So I.
Your eyes look a little funky.
There's a reason I write them that way.
How much? I squared to represent small.
Yeah, when I write, I get lazy and I may forget the dot.
Okay.
So then that could be a 1 or an L or whatever. So I write my eyes with script. It's not really a Z. That's the eyes curl.
Because you're writing person by.
That's not cursive. That's a cursive I. That I is math script. I don't know why I just wrote 20. I write them as complex. Well, root 20 is 4 times 5, right? So again, I can just write that. It's 2 root 5. We're gonna get what? -6 times 5, so -30. Then I squared, which is just 30. You did. Right, so I is the imaginary number. This is already in I format, which is nice. Be what? -12 I squared, right? 4 times -3, I times I, which is just 12. Six I quantity squared. Again, think of I as a variable. Right, each term just gets squared. That gives us -36. Right? Two times root -1 would be 2I. So this is just 2I cubed. What's 2 cubed? So this is 8I cubed. I cubed. I squared times I, right? -8I. So I cubed equals negative I. What doesn't make sense?
Like the end result doesn't make sense, but we do it.
So, for number 5, the beginning, the 2, sort of -1 cubed. How did that go from that to the 2 I cubed?
Square root of -1 is I. Right? Because I squared is -1.
Yeah.
So I is the square root of -1.
I'm trying to get a variable by square.
Again, it's not really a variable, it's a complex number.
Yeah.
But think of I as like X, right? And then all of the algebra you used still apply.
Can't simplify that.
That's fully simplified.
Square, it's not close.
Right, I squared is -1. Right? You never want I to a power. Right, so I to a power will always simplify. Three I times I plus 2. Distribute. Be 3I times I, right? Just 3I squared. Then be plus 3I times 2. Get -3 plus 6I. Three minus 2I times 4 plus I. We have to FOIL. 3 times 4. Then it'll be plus 3 times I. Then plus -2I times 4. Plus -2I times I. Right, so that's -2I squared. You can combine like terms. 3I minus 8I would be -5I. Then minus 2I squared comes plus 2, doesn't it? This product is 14 minus 5I. Five minus 3I times I plus 2. 5 times I plus 5 times 2 plus negative 3I times I plus negative 3I times 2. That becomes 13 minus I, doesn't it? Five plus 3I squared. Well, you can write this as 5 plus 3I times 5 plus 3I, right? We can also just use the binomial theorem to expand this out. 5 squared plus twice the product of 5 and 3I plus 3I squared. That'll be what, 16 plus 30I?
Well, then, it's the same answer, right?
Product of 3 complex. Pick 2 and FOIL them. Let's just look at the first 2, right? 6 plus 4I minus 3I. That's minus 2I squared. And then times 1 minus 4I. Six plus 2 is going to be 8. And then we get 4I minus 3I, which is just I. So that's the good news about complex numbers, right? Even though it's behaving like algebra, once simplified, it's always going to be a binomial. And then just FOIL it again, right? We're going to get 8 minus 32I plus I, then minus 4I squared. And so I said you should have done this in algebra.
Yeah.
8 plus 4, 12. And we get minus 31I.
comments had me so confused. I was like, is I coming from?
Two ways to approach this problem. Could go ahead and just use binomial theorem. Or we could factor out that common factor of root 2 over 2. Doesn't matter. I'm just going to use binomial. Root 2 over 2 squared. A half. Plus twice their product. So root 2 over 2 times root 2 over 2. Doubled. So it's just plus I. And then root 2 over 2 I squared is going to be 1/2 I squared. One half plus a half I squared is 0. We're left with I.
I just don't know why they. 1/2 plus I.
Twice the product of the terms. Right, so root 2 over 2 times root 2 over 2I is a half I, isn't it? Double it. Half times 2 is 1, isn't it? So it's I. So think of I as X. If this was, let's say, A plus BX all squared. Remember that formula from algebra? A squared plus 2AB, right? And then plus B squared. That's all we did. One plus I cubed. Couple ways we can go about this. Could write that as 1 plus I squared times 1 plus I. Right, FOIL out the 1 plus I squared, simplify it, and then multiply it by 1 plus I. Or I can just use the binomial theorem again to expand out a binomial cubed. The 1 cubed plus 3 times 1 squared times I plus 3 times 1 times I squared plus I cubed. Way back, first day, Pascal's triangle. Now it's just a matter of simplifying this. 1 plus 3I squared, -2. 3i plus I cubed plus 2i. And there's 1 plus I cubed. What about negative I?
Wait, what happened to the I cubed?
That's negative I, right?
So.
What's 3i minus I? What's 3i minus I? 2i.
But if the I squared would be a -1.
Right.
And it's 3 times a -1, so it's a -3. So we're gonna,
Right, so 1 minus 3 is -2, right?
yeah, that makes sense. And then the,
Right, then you have 3i plus I cubed, which is 3i minus I, which is 2i, right?
So that point is just 2i.
Yeah.
You already did the I cubed.
Yes. I know I cubed is negative I, so I know 3i plus I cubed would be 2i.
Oh, lost them, you got 2i, but you just did that step without showing us.
Because I did it before.
Doesn't really see.
That's not nice.
I'm saying it's myself.
That's not nice. I'm again going to use the binomial on this. 3 cubed. Now, notice that this is a minus b being cubed, right? So the signs alternate. Next term will be minus. 3 squared. Nine times 2. Right, 18 times 3. So 3 times 2 squared. Times 3. Third term is 36i squared. Two cubed. Final term is minus 8i cubed. Be 3 squared. Times 2. Well, technically times 2i. And then that whole thing gets multiplied by 3. Right? Pascal's triangle, that row is 1, 3, 3, 1. So the coefficients are 1, 3, 3, 1.
So square would just be 2, right?
Right, because if it was squared, right, then that row is 1, 2, 1. That's why you double the product.
So, all right. Can you just do a simple A minus B cubed showing that freaking binomial theorem?
Just write out the formula.
Minus B cubed. Okay, all right.
And if it was squared, it would be,
A squared minus 2ab plus b squared. Oh, I'm not done with this problem yet. Oops. We're going to wind up with 27 minus 36, which is -9. Then we have -54 plus 8 is -46. Notice the only difference is instead of minus, it's now plus, right? So no need to reinvent the wheel. Those just become plus instead. We're still gonna have 27 minus 36, which is -9. But now we have 54i minus 8i, which is plus 46i. One plus 2i to the 4th power. How do I want to do this one?
But as quantity 1 plus 2i quantity squared,
I
and
could.
then just square the result.
I could. That wouldn't be as fun though.
What, binomial theorem?
Yep. 1 to the 4th. Yep. 1, 4, 6, 4, 1. 1 cubed times 2i is 2i times 4 1 squared is 1. 2i squared, 4i squared, right? That gets multiplied by 6. Two I cubed, 8i cubed, right? That gets multiplied by 4. Because it's times 1, which is just the same thing, right? And then it's 2i to the 4th. Which is what? 16 what? So there's your expansion. We'll deal with that 16i to the 4th separately right now. 24i squared is minus 24, right? 1 minus 24, negative 23. Then we have 8i minus 32i, which is negative 24i. Now we have to deal with that 16i to the 4th. Let me actually do that separately. Do that like right here or something. Let's look at I to the 4th. Isn't it I squared squared? Which is what? I to the 4th is positive 1. I to the 4th is then just 16. So I to the 4th is positive 1. What do we think I to the 5th is going to be then?
I.
Just positive I. Which means it repeats every 4th power. Right? You have I. You have I squared, which is minus 1. I cubed is minus I. I to the 4th is 1. I to the 5th goes back to I. So I to the 6th would be minus 1. I to the 7th would be minus I. I to the 8th would be 1. Then I to the 9th starts over. Back to I. Negative 23 and 16. Negative 7. Negative 7 minus 24i. Negative 1 plus I raised to the 8th power. I mean, I was going to be nice, but since someone just pulled out Nutter Butters in front of me and didn't offer me one, now I'm going to make him do this using the binomial theorem. Maybe I'll have him finish off the rest of the class.
That will be great for everyone.
This will be a lesson he'll never forget. Never pull food out in front of your instructor. Unless you offer them some.
Um, well, my Pascal is only up to row 6.
Oh, that means you have to go down to row 8. It is not fun. It is not fun.
6, 70. Jesus. All right, so you're, no. I mean, Pascal coefficients are 1, 7, 21, 35, 56, 70, 56, 35. No, wait, what? 1, 8, 28, 56, 70, 56, 28, 8, and 1.
That does not sound right for the 8th row. Shit. Might be, I don't know. I haven't memorized down that far.
I mean, we could spend a whole class on this one.
1, 7, 21, 35, 35, 21, 7, and 1.
Well, that's 7. We want 8. We want the one after that.
1, 8.
Now the 70 sounds right. Yeah, so that's right.
Okay.
Good news is the coefficients are 1. So I'm going to change it for him. Oh, wait, no, that can actually be made easier. No, it can't be. That's what you get to do. Using Pascal's triangle and no calculator.
I'm not gonna use Pascal's time. I'm
You have
gonna
to.
do the way that I said.
No, you
before.
have to. This is going to be your test question. It's going to be Pascal's triangle.
Can't you just like put the. Can't you just make it I-1 and put that?
You can. You could. That wouldn't be any fun.
Seems much easier than that.
It is, but easy isn't fun.
Yeah.
That's actually what I'm going to
So,
do.
like, can we start?
I'm not
with-
using Pascal's triangle.
Oh, no, can we start with like the fun way? Your definition is fine,
Let's see if it's easier.
and then like the easy way.
If I do it the Pascal triangle way, I'm just going to plug it into Mathematica.
The 16.
Yeah.
This is how I'm going to tackle it.
That's
Yeah, this is valid. This is valid. And there's a reason why for this one I'm doing it this way.
the brute force method.
Well, I would say what we've been doing is the brute force method. This is the clever method. Be what? 1 minus 2i plus I squared, right? To the 4th. Which just becomes negative 2i to the 4th, doesn't it? Which is just 16.
I squared. Plus 1 is.
All right, so we've looked at, and technically we did add complex numbers. Right, so adding, subtracting complex numbers work the same way, you just combine like terms. We just spent all that time multiplying complex numbers. about dividing complex numbers?
Paper.
That's why technology is grand. I never run out of paper. The dimensions of my one page are infinite.
Do like the lowest common whatever.
This is where you'd use the conjugative of the
Additive,
conjugative,
conjugate.
conjugate of the denominator. Well, whatever the denominator, the conjugative of that, and the symbols will switch.
What do you do with the conjugate?
We have to time it.
Right, so you take the conjugate, but then what do you do?
The numerator
Not just the numerator.
Well,
and the denominator.
you create the conjugate over conjugate.
We rationalize it.
Yeah.
Right. Just like in algebra, when you rationalize when you had a square root in the denominator. That's what we're doing here. Right, because the idea is you do not want I in the denominator. We're going to get in the numerator 3 plus I plus 3I plus I squared, right? And then the denominator, notice that is a difference of squares. Just be 9 minus I squared. Right, your middle terms would cancel out with difference of squares. Be a positive 1, right? Denominator then is 10, isn't it? Numerator 2 plus 4I. Which is not simplified. Your book doesn't like that. Because that is not technically of the form A plus BI.
You have to split it up.
Oh,
Your book wants it written this way. In fact, every text, every beginner's text on complex wants it written this way. Even though they're the exact same thing.
Like this division was easier than the multiple. This problem, I guess.
Too late.
So they.
Anything like a square root in each one.
This one's not bad. Technically, we should be multiplying by negative I over negative I, right? Which is just the same thing as multiplying by I over I. Doesn't matter.
Why is it the same thing?
What's negative 1 over negative 1? So you can just drop out the negatives. Doesn't matter, you get the same answer regardless. I over I squared. I squared's minus 1. 1 over I is negative I. So the pattern works in reverse if you start to decrease the powers of I, right? I is I to the 0 is positive 1. Then I to the minus 1 would be negative I to the minus 2 would be negative 1. And then I to the minus 3 gets you right back to I.
It's is it still every 4?
But remember, it's going to look differently now because you're going in decreasing order, right? So you're going from I to the 0, right? Then to I to the minus 1, I to the minus 2. Just for you. Because you said it was too easy. So it was easier than the multiplication.
I didn't say that.
You did.
Oh,
No, you have to do 28 minus 31i to the 8th power using Pascal's triangle because you put out another butter. You didn't offer me one.
I thought you might have a peanut in it.
Really?
I was being
Does
considerate.
it look like this has any allergy to foods? The only food I'm allergic to is not having food. Sadly, my son look after me in that regard. Bastard eats everything. God forbid you make yourself something and sit down. He could be asleep and he'll smell and wake up and come running down. Thankfully, he used to eat just about everything. Now he's picky. I shouldn't say picky. He knows what he wants at that particular moment. That's all he's going to eat. But the next moment it'll change.
I'll just look at the problems down in which start.
Oops. You still have to multiply by the conjugate, right? Because we're still rationalizing. Numerator. 2 times 3 is 6. Root 3 times root 2 is root 6. So first term, 6 root 6. Then we get what? 2 times 4 and then root 3 times root 3. So it'll be 8 times 3. 24i. Root 2 times 3 root 2 is just 6, isn't it? Root 2i times 3 root 2. Right, those are the inners that I just did, right, of FOIL. Now I'm doing the outers. Be plus 4 root 6 I squared, right? Denominator is difference of squares. So 3 root 2 all squared would be 9 times 2. 18. Minus 4 root 3 I all squared. 16 times 3. 48. So there's your denominator. Six root 6 minus 4 root 6 is what? Yeah, 2 root 6. Plus 30i. Then it's 18 plus 48. 66. Add the what?
Just combine into one.
I mean, technically we did, right? It's 6 root 6 plus 4 root 6. Factor out a root 6. That becomes 6 plus, I'm sorry, minus. 6 minus 4 all times root 6, which is 2 root 6. Right, you can't do, so remember, root A plus root B is not root of A plus B. But since that root 6 is common, they get absorbed together. If that was root 7 instead, you couldn't simplify that. Yeah, no, you. You're not allowed to add across square roots. And then when you simplify that, root 6 over 33 plus 15 over 33i. See, that wasn't so bad. Any questions on complex numbers?
With the 6, the 6 and the 6 and the 4. Was that 6 root 6 and the 4 root 6?
Mhm.
You wouldn't do like the 6 and the 4 wouldn't add together.
They did. But remember, that's I squared. So it's
yeah.
minus 4 root 6. That's why it's 2 root 6, right?
So when you take the I squared, that it becomes -1
Yep.
for the 4.
Yes.
Not the 6 inside.
Correct. Right, because the I squared is not under the square root.
Back to the 4.
Download the newest version yet.
I love it.
Line.
That's okay. You know what he gets to do now?
I never like.
The one time you have.
He gets to do that using Pascal's triangle.
Back up. Look.
That was nice and did 15th power. Hmm? 520. I to the 22nd power. Can't write that as I squared to the 11th. Which is -1. I to the 22nd is -1. We have that. Ooh, me too.
If you just go stick around.
Hmm?
If you didn't just go stick around.
Well, I know I didn't. I wanted to see if the other one I was looking at is the problem I gave you. And it is, so I'm glad I'm not doing that one. Guarantee you I could have done that one and I'd still have people not get a 10 on the quiz. I've done that before too, where I put a example we did in class on a test. Literally the exact same example. I think maybe 2 people got it right. Made me sad.
What happened with Monday's quizzes?
Haven't graded them yet.
Oh, maybe you decided to just discount that.
Nope. I already skipped number 2. I already skipped the second quiz.
Really? What if you did well on it?
I didn't even do
Didn't give it to us.
it. We didn't do it.
was a great post. Oh,
It's just there for continuity. It's not worth anything. So normally you would say, oh, find a common denominator and add them. Right? No.
You have to multiply.
You have to do the divisions first, and then you have the sum of 2 complex numbers.
Then you'll come back to this.
And then we'd add them together. Well, the first one's easy, right? Because 1 over I is -I. So it would be -I times 4 plus I. Then it'd be plus (3 minus 4I times 1 plus I) over, and I'm just going to do the difference of squares. 1 minus I squared in the denominator. Negative I squared is 1. I get what? 3 plus 3i minus 4i minus 4i squared all over 2. Three minus 4i squared is 3 plus 4, which is 7. Three I minus 4i, negative 1. So this problem is 1 minus 4i plus 7/2 minus a half I. All right, now adding complex numbers. Just add like terms, right? 1 plus 7/2. Then we get negative 4 plus negative a half is also minus 9/2. So there it is, 9/2 minus 9/2 I. What would be positive? Why would it be positive?
Change it to a positive.
I squared would if it was I squared, but it's not. Then James, just see me after class. I have information for you.
So, I'm sorry, that was 9/2 minus 9/2 I.